Hi, good morning, everyone. Welcome to this session. So, first of all, thanks a lot for coming over here in your morning schedule. So, thanks a lot for that. So, what I'm going to be doing, what I'm going to be talking about today is share with you some of our analysis or our experiences with working with the telcos, particularly on NFV deployments. What are some of the key challenges that we have seen telcos face as they march forward in their virtualization journey, and what are some of the key solutions that VMware is able to bring to the table to address those challenges, and also essentially talk about what are some of the key gaps that we find in the OpenStack offering itself, right? So these are some of the key things that I wanted to cover in the next 30 minutes or so. But before I actually jump into it, I just want to understand, by just show of hands, do we have any telco representatives in the room here? I mean, do we have any? Oh, that's quite a large contingent. Thank you. Thanks a lot for coming in. So, so let me just jump into it. So first of all, what are some of the key needs for virtualization from a telco standpoint, right? So let's walk through them one by one. So first thing is secure multi-tenancy. I've been in this telco industry for about 20 years now, and the way the telcos are typically organized internally is in terms of specific siloed vertical teams which are responsible for handling specific functions. Like, for example, there will be a group which is primarily responsible for handling EPC functions. There will be another team which is responsible to handle IMS functions, another team for GI LAN services, right? So in the physical plane, these teams used to procure their appliances independent of each other, and they used to manage their own appliances independently as well. But once you go to the virtualized LAN, everything is going to be co-located. But now you don't have this kind of mutual isolation between an EPC application and a IMS application. So in a sense, what could happen is an EPC application could step into the performance of your IMS application, right? So the noisy neighbor scenario and things like that could crop in. Another important problem is you have a common virtual infrastructure, right? And each of these groups are making independent decisions from a scalability and capacity expansion standpoint. Again, one group could consume a lot of resources in a quick succession in a week or so because of a huge rollout, and this will essentially consume capacity that was the planners had dedicated or kind of planned or assigned for another team. So how do you ensure that each of these independent teams get the best out of the virtualization platform, but at the same time do not step into each other's toes, right? So that's a key requirement that the telcos have, and that's what I'm calling here as secure multi-tenancy. And again, another thing, if you had attended the previous session, Marcos talked about multi-segmentation, where from a threat standpoint, it's not only sufficient that you protect your data center at a perimeter level, because once people penetrate your perimeter and get into the core of your data center, now they have a free license to basically impact all the other VMs that are running inside your data center. So you need protection in the east-west traffic as well. So that's what I'm labeling here as a secure multi-tenanted capability, right? So this is one need that we do have here. The second thing is guaranteed resource isolation. Many of us have, are not local to Vancouver. We have been flying a lot, I'm pretty sure. But I've experienced this a lot of times. When you go to an airport, you may have a confirmed ticket, but when you're in the gate, that's when the travel agent announces, hey, we are overbooked. Can one of you take the next flight, right? Why does that thing happen? It happens because of this overbooking scenario, right? But in a telco parlance, that is very, very bad, right? Because when you want to launch your service, like when you want to roll out your service for millions of subscribers, and all of a sudden you figure out there is not enough capacity to run your workloads, then that's a big problem for the telcos, because they have significant SLA commitments to their customers as well as to the government, because telcos, at the end of the day, it's a big regulated industry, so they do have to answer to the government from an availability standpoint. So the resource guarantee is another key element that telcos require in their virtualized infrastructure. Right? The next challenge that I do see is, there is a lot of talk going on today about 5G and edge computing and the next generation of distributed cloud architecture. Now, what I'm showing here is just a very high-level abstracted picture of a distributed cloud architecture, right? But the key thing here is when you have these multiple clouds, how are your workloads that are instantiated in these independent clouds going to interact with each other to realize a network service for your enterprise customers, right? So that's a key thing, because not every single service is likely to be self-contained within a cloud. Like, let's take, even if you take a simple example like a IMS application, for example, right? The subscriber authentication aspect of the IMS application, that's likely to be centralized. But your video transcoding part of your IMS application, that could be decentralized, right? So in essence, what it means is you're going to, effectively, you're going to have applications which has some components residing in the edge closer to the device or closer to the subscriber, but other elements that are going to be existing in a centralized cloud. So you need to provide seamless interactivity between them. And the other piece is, as load increases, as new subscribers come on board, you may run out of capacity in your edge cloud. So now we need to think of scenarios how you can move that workload or augment the capacity in your edge by allocating additional capacity in your centralized core. So those are some of the scenarios that are going to become even more predominant as we deploy the distributed cloud architecture. So that's another challenge that that is going to crop up, like hybrid cloud migration and also migration under disaster, right? So here is an example that I'm saying. So here in this case, we are just taking a simple migration scenario where you have a VM that is running in your core data center and you want to migrate it to your cloud, right? So then the other scenario is, let's assume that you want to this entire data center goes down, right? So now we need to somehow the system needs to recognize that a data center has gone down, and it should automatically migrate all those VMs to another available cloud so that at the end of the day, the service continuity is maintained, right? So this is a very important requirement from a distributed cloud standpoint. So the next one is network slicing, right? So this is a very classic use case in the 5G scenario where telcos want to slice their network logically into separate sections, and then assign each of those slices to a specific enterprise customer or for a specific use case. For example, if you're talking about it's an autonomous car kind of a use case. So there could be GM coming and saying, okay, I want to purchase a network slice to manage all my autonomous car deployment, autonomous car services. So then what AT&T or Verizon will do is essentially take the entire network spectrum and create a slice out of it, and then allocate this particular slice to Verizon. But that requires a lot of things, right? That not just you have to slice it not just at a compute level, but you also need to slice it at a network level. And another thing is the components could exist in different places. For one slice, your EPC component could be the edge. For another slice, EPC components could be in the core, because that's how that particular enterprise or that particular slice owner decided to deploy the network. So how do you manage all these variations in a single virtualized infrastructure, right? So that's the challenge that I'm talking about here. So the next one is a carrier grade. I mean, this is something that has been bread and butter for the telco industry. So when I say carrier grade, definitely performance is a key element. But more importantly, the integration requirements of a virtualized infrastructure with other telco subsystems, like your orchestration subsystem, your billing subsystem, your authentication subsystem. So all these things. This is extremely important as well. And then from an upgradability standpoint, right? So when you upgrade your software, at the end of the day, these are all software components which will require frequent upgrades, right? I mean, at least once a year, I would anticipate many of these applications requiring an upgrade, right? So when you do such upgrades, you still need to maintain service connectivity. each upgrade cannot result in a need for a maintenance window. Right? If that becomes the case, then it becomes very, very problematic for you to maintain your SLA and at scale. Right? That's a key thing. Right? So, so that's another key element. Right? So these are some. So the next one is from a operation standpoint itself. Right? So at the end of the day, this is a very, very complex and large system. There are going to be issues, right? I mean, let's be honest about it. There are going to be issues. Now, the question is, how are we going to identify the issues, root cause the issues, and fix it as quickly as possible? In places where it is possible, we should be able to take proactive corrective measures, right? You shouldn't be waiting for the actual problem to occur. We should be able to look at the trends. From the trend analysis, we need to be figuring out, hey, this is what is likely to happen later on, maybe 1 hour down the line or 1 day down the line, and take corrective action immediately, right? So that's another key element. And remember, this is a virtualized plane, so you cannot necessarily pinpoint a particular element which is experiencing a problem. And also, this is extremely dynamic. VMs are constantly moving around. So your UPC application could be in an edge cloud now, and due to some load characteristics, you may have bursted it to a public cloud. So now it has all of a sudden it has gone to a different cloud. But still, you should be able to identify that something wrong is going on and be able to troubleshoot and fix the issue. So these are some of the key challenges that the telcos face in deploying NFV solution. So how does VMware address these challenges, right? So we just announced VIO 5.0 earlier this week. So one of the key capabilities that we introduced in VIO 5.0 is this tenant VDC concept, which essentially provides you an elastic and guaranteed secure multi-tenancy. So essentially, the entire virtual infrastructure, right, whatever is the amount of resources, let's say you have 1,000 core infrastructure, we take this entire 1,000 core infrastructure and split into multiple partitions. And these partitions are then allocated to individual tenants. So once it is allocated to individual tenants, any other tenant cannot utilize this particular tenant's resources. So naturally, by just partitioning your resource and allocating to individual tenants, you achieve multi-tenancy, you achieve resource guarantee, and you also achieve resource isolation. Like, people cannot be stepping into each other's stores, right? And this is done not just within compute, but it is again across compute, memory, network, and storage, right? So that's really the concept. So that way, the entire virtual infrastructure, you can partition and give it to individual tenants. The other piece is the elasticity aspect of it comes from the fact that initially you may probably create a partition of, let's say, 100 cores, but later on, if you want to expand it, then you should have an ability to do it. So that's what the elasticity means. You walk in with an initial allocation of 100 cores, but later on, if you want to expand to support additional workloads, then you can expand it to 200 cores. But while you do that expansion, your existing workloads are not impacted. They continue to run. They are not migrated. It's all in place, no impact to them. It's only we are adding additional resources on the far end of the resource pool, so as to speak. So we talked about the hybrid or a distributed cloud architecture. Another offering that we have is our NSX hybrid cloud product, when it's also called as HCX. So this one provides connectivity between different clouds. So once you establish the VMs that need to participate in this hybrid connect scenario, then the system will automatically take care of maintaining the state across these various clouds and ensure mobility across these clouds. So one of the key things here is hybrid interconnect. So you have any to any kind of DCI interface, right? So once you define the two cloud endpoints, then the system automatically takes care of interconnecting the two. Then hybrid workload mobility, like you can dynamically move VMs from one cloud to another cloud with no service impact. So that's the key thing that we need to understand here. So similar to vMotion, I mean, vSphere already supports vMotion, where there is no impact to your running workloads, right? So the same vMotion is now supported across the various clouds, right? Be it private to private or private to public or public to public. It doesn't matter. So that's the inter-cloud VM migration capability. The last one is disaster avoidance, right? Once you have identified a particular cloud to be protected, and you have identified another cloud to be this cloud's backup, then the system will automatically monitor your current running cloud, and whenever it detects any problem in this cloud, it will automatically move the VMs, like what we saw in the previous slide. It will automatically move all the VMs in this particular cloud to your backup site, right? But it's not going to do the state sync only at the time of disaster. It is continuously syncing the state. So that way, when the disaster happens, the amount of data that it needs to transfer is very, very minimal, right? So this is a distributed cloud reliability functionality that we provide through our HCX product. So how do we achieve this? I mean, as you can see here, we have multiple agents sitting in each of these clouds, which are automatically identifying the protected workloads in the individual sites, and then it is constantly syncing the state of these workloads in its designated backup site. So when anything happens to this VM, then the migration becomes extremely smooth and fast. So that's really the concept behind this particular offering. So the next one that I have is compute availability vSphere HA. Some of these functionalities you may be already familiar with, right? So if you look at vSphere, for example, we already have an inbuilt HA mechanism. So the HA mechanism, what it does is it constantly monitors your VM status, and if it fails, it will automatically spawn another VM. But we do use VM replication methodologies to replicate the state of this VM on the backup server. So that way, when you do have to kick off, when you want to power on a new VM in place of this failed VM, the state is kind of maintained, right? So all of that is already available in the product today. The other feature that we do have is vSphere fault tolerance. The fault tolerance is a classic fault tolerance model where you have two VMs running active in they are running concurrently, but only one of them is active in the sense one of them is the only one which is connected to your client, right? But any input output that is going to this particular VM is replicated to the other VM as well. So when this VM goes down, there is no vMotion required. This the backup VM or the fault tolerant VM has all the state. Because it is running in a backup mode, it has all the input-output messages being sent to it, so it can immediately become active and start responding to requests. So that's the fault tolerancy that we do support. So these things provide significant availability for telcos, right? When you're talking about 5 nines reliability, when you're talking of 5 nines reliability kind of correlates to about 5 minutes of failure time in a year, right? Approximately that's the equation. But if you want to achieve that level of availability in a virtual infrastructure, you need capabilities like this at the infrastructure layer. It's not sufficient for us to do just at the application layer, but we also need to do it at the infrastructure layer, and that's what I'm talking about here, right? So the next one is from a performance standpoint. So this is something really important, like telcos run a lot of data plane workloads like EPC, DPI processing, and things like that, which does require fast packet processing, right? And it's not only important for us to provide higher throughput. What is also important is we need to keep the latency to the bare minimum, and we also need to ensure that the flow does not experience any jitter, right? So that's really what the expectation is from a telco deployment standpoint. So what we are introducing in the next month, we will be announcing this as part of our NSXT offering. We are introducing a new mode of operation for our virtual switch, and that is called as Enhanced Data Path Mode. That's what is abbreviated here as EDP. So in this Enhanced Data Path Mode, the switch functions as a DPDK-enabled virtual switch, right? The one difference between our implementation and the OVS implementation is that the DPDK libraries in our implementation is there in the VM kernel. So, and that gives us additional scalability and additional performance boost, right? So that's a key advantage that we have. But as you can see in the figure, in the numbers that I am displaying on the right side over here, we are seeing anywhere from 3 to 5x performance boost in comparison to our regular virtual switch, right? 3 to 5x performance boost. Now, another important thing is when you're talking about any DPDK-based virtual switch, there are two things that comes to your mind. One is is your switch scaling linearly, right? Like when you add additional cores to do the dedicated pull mode processing, is my throughput increasing as a linear function, or is it increasing as a flat function, right? So what our switch is experiencing is more of a linear scalability curve, right? So that's what it is experiencing. So as you add more cores to process your traffic, the additional incremental throughput that you experience is pretty much the same. It's pretty much constant. The another aspect that is also very key is from an application standpoint, it should be seamless, right? You don't want to rewrite your application because applications most of the times are already pre-developed, right? So you don't want to make any changes in your application. You don't want to even recompile the application if you can, right? And that's what this one achieves. Because the implementation is at the kernel level, there is zero impact to the application. You just need to use the standard VMX Net3 driver, which you have already been using, so there should be no change for that. And underneath the covers, instead of binding to a regular virtual switch, you will bind to the virtual switch operating in the EDP mode, and then automatically you achieve the benefits of DPDK, right? So that's a new thing that we are introducing. Currently, it is going to be supported in 2 NIC variations. We are supporting the 10 gig and the 40 gig variation of Intel NICs. But we are in conversations with additional NIC vendors as well, and more solutions or more interoperability under that particular topic will be announced in coming months. And we also support SRIOV for those workloads that require SRIOV. That is also supported, SRIOV as well as direct pass-through. So we have the full gamut of networking, a highly performant networking layer. The next one is from a hybrid workload standpoint, right? Today when you look at most of the workloads, they all have a VM form factor. But this is likely to change in the coming years, right? Many vendors, when I talk to them, they are all announcing plans, or they already have plans in some cases, to containerize their entire control plane and data plane, right? So, but the point is, they are not going to containerize their application in its entirety in any short duration, right? So there is going to be a period of time where some components are going to be containerized, other components will continue to exist in a VM form factor. So this hybrid workload is going to be a phenomenon for some time to come, right? So in that scenario, how would I instantiate this hybrid workload in an OpenStack or in a single virtual infrastructure, right? You don't want your container workloads to be completely independent of your VM workloads, because then stitching those two and managing those two becomes problematic. So what we have as part of our VMware integrated OpenStack distribution is an integrated Kubernetes distribution as well. So we call it as YOK. So that's what is showcased over here. So we run a Kubernetes a pod within the VM that is managed by OpenStack. So your full Kubernetes thing can be realized through OpenStack, and all your container management and everything you run it through your Kubernetes controller and all other container-based tools. But when it comes to infrastructure itself, that's instantiated in a VM that is managed by OpenStack. But the key differentiator is this one. When you're talking about networking, right, you don't want 2 different network islands, one for your VM land and another for the container land, because then again you need to do a lot of manual work to stitch those 2 together, like particularly in a hybrid workload scenario. So what we include is a NSXT The NSXT comes with an integrated container plugin. So with the use of this container plugin, now you can stitch a network in the container world and connect it to the same network that is extended into the VM world as well. So both your VNFC in the VM form factor as well as your VNFC in the container form factor can exist in the same network, right? So that's a key differentiator that we are bringing to the table as part of this particular offering. Next one is from a availability and an operations management standpoint, right? So there are three major aspects that we need to consider when you're talking about operations management. The first one is continuous performance optimization, right? This one is essentially how do you continuously monitor the functioning of your system, identify performance hotspots, and take corrective actions to ensure that the system is performing as expected or as designed for, like from an SLA standpoint. So we do have some tools in order to help you carry out this particular objective. The second one is capacity management. At the end of the day, people move to virtualization for two reasons. One is for service agility. The other is the potential cost savings, right? Now, in order for you to achieve the potential cost savings, you will have to do some sort of overloading or workload, compression kind of a thing, right? So that's what we are talking about here as efficient capacity management, where we have some specific tools that monitors the capacity usage of your environment, and you can set policies like how you want it to be. I mean, do you want your VMs to be distributed, or do you want it to be powered on in a way that it conserves the energy, overall energy of your data center? So there are several parameters that you can leverage to guide your system, right? So that's the second aspect. And the third aspect is from a remediation standpoint. This is what I was talking about earlier. It's in the telco scenario particularly, it is not sufficient for you to provide tools that help you fix a problem. You want to be able to recognize the problem before it actually happens and take proactive remediation. So that's what we are calling it as intelligent remediation, right? So one of the functionality that we have here is called as predictive DRS. DRS stands for dynamic resource scheduling. So what happens is this: we have a tool called as VR operations, vRealize operations. So this continuously monitors the health of your servers. And whenever it detects a trend, a deteriorating trend on the server health, it will mark this particular host as a host under risk, and it will proactively migrate all the VMs out of this particular host to a different host and initiate an alert, or it basically notify the user saying, hey, this particular host needs to be taken down and please go and do additional diagnosis. Now, this is happening in a predictive fashion, right? You're not waiting for the server to fail before you can take care of the problem, right? So this is what we are talking about, being able to proactively identify issues and remediate them ASAP, right? So that's really the key requirement for telcos, right? Also, the other aspect is, let me play this out. Another aspect is in the physical LAN, right? When you're talking about networking in the physical LAN, it was very, very simple. You knew exactly when a packet has to go from point A to point B, you know exactly what are all the intermediary components. Because the topology is laid out, you may even have it laid out in a piece of paper, right? And it's not going to change. It's going to be exactly the same today, tomorrow, next year, and so forth, as long as you don't add additional components and so forth. But in the virtual form factor, in a virtualized environment, that's never the case. The topology is constantly changing because your VMs are constantly moving, right? So what happens as a result is when you have a networking issue, right, either a particular VM loses connectivity, or a VM is unable to reach another destination, then troubleshooting this particular problem becomes challenging in a virtualized environment. So what you need is a tool that can picture or capture the topology of the network as a time series database, so that you can go back and check, okay, what exactly happened when this failure occurred, right? So that's what we have as part of our vRealize Network Insight product. So this integrates into the NSX fabric, and it collects alerts and information at the networking layer, and it and it stores it in a time series database, so that later on when you face any issues, you can go back to the time series database and identify what exactly happened at the time the failure occurred. Right? And it gives you a pictorial representation of the topology. You can also do path tracing and things like that. So that's the network insight tool, which helps you from a virtual networking standpoint. So far we just covered what are the challenges, needs, and how VMware is addressing some of those challenges. So what I would like to talk next is some of the key areas where we feel that OpenStack as a community needs to address immediately in order to make this more relevant for the telco world, right? The first thing is roles and role-based management. Now, I talked about how telcos are internally organized into different teams, right? But when you look at OpenStack, you don't have that level of role-based access control. It's not that granular. Right? So it has RBAC, it has some capabilities, but it is not as granular as what one would envisage that you have for a telco use case. So this is one area where I think that OpenStack has to really pick up the tab and add some additional capabilities under this. The other thing is resiliency and autonomy. I mean, I do see this being talked a lot in this summit, which is really music to my ears. A lot of people are talking about introducing resiliency when it comes to a distributed cloud deployment. And another aspect that which is also very, very important is the autonomous operations, right? Once you have thousands of clouds, you cannot expect an administrator to be sitting and managing each of those clouds. It's just not possible. It's practically impossible. So what you need is a API-based mechanism, a autonomous management system where you can specify your intent from an operator standpoint. You may want to say, okay, this cloud, I'm designating it to address all my connectivity for this particular area of Vancouver, and I want it to be running only your EPC workloads locally. Right, or something like that. You specify your intent, and then the system should automatically take care of implementing the intent. Right? So it should have that autonomy to manage itself and be able to address failures as well in an autonomous fashion. Right? So this is going to be extremely key, and as a community, I think OpenStack will have to step up and provide some targeted capabilities to address this need. The third one is a deployment of hybrid workloads. I do see some work that is being started, like Curator and other such projects. But the point is, you need to expand this and make it relevant to the telco workspace, because it is not just sufficient for you to connect these two workloads, but now we need to talk about scaling, scale up, scale out, and also in terms of day two management, that capacity increases. What if your VM and your container are in two different clouds? So things like that, right? Those kind of scenarios are something that is still needs a lot more work in the community. And then the last piece is something that OpenStack has been, lagging behind, I would say, because from a support standpoint, what carriers do need is a long-term support, particularly for an infrastructure, right? Typical expectation is around a 5-year support window, right? But if you look at OpenStack Upstream, they only offer you about 2 years at the max, right? Even that is very, very spotty. So this is another area where we do, as a community, need to step up and have some kind of solution or offering targeted to the telcos. So I think that was my last slide. So I think we do have some time for questions. So if you have any questions, I would be happy to take them now. Thank you. Sure. Can you please use the microphone if you don't mind, so that.
Thank you for the presentation. It was very clear. I work for a company that sells to telcos, and our experience is that the issue of the data performance, the speed of the data plane, was a big issue until now with relation to VMware, and you're just talking about addressing it now. So I'd like to hear more about that, because this is, I think, a main inhibitor for telcos choosing a more VMware-based cloud solution.
Sure. So as I announced, let me go back to that slide. So yeah, so as I announced here, next month we will be launching our DPDK-based virtual switch. So that gives us about 5x performance, but 3 to 5x performance boost over our regular vSwitch, which is what you have been using probably in your customer interaction so far. So when I talk about packet performance, there are a couple of things that we need to be cognizant of. One is raw throughput numbers, right? That goes without saying. You need to have some real strong raw throughput numbers. But more importantly, what you need to also ensure is vertical NUMA alignment. I did not talk about this in my talk, but you need to have vertical NUMA alignment in order to make it consistent for a longer period of time, right? Your VM, your L-core, and your NIC, all three of them need to be vertically aligned. Now, you can do that vertical alignment in a manual way, but then you are not operating under the principles of virtualized environment, right? You want this to be taken care of automatically. So what we are including as part of our DPDK-based virtual switch is a embedded load balancer, which will automatically align your VM processing cores, the dedicated cores which is processing DPDK, as well as your NIC. All of them will be vertically aligned. So you don't need to do, you as a user, you don't need to manually go and configure anything on that particular layer, right? So that's what we are working on. One is providing raw performance, but more importantly, providing a ease of operation so that a telco administrator doesn't need to do a whole lot of things when he goes and configures for DPDK. And the third element is when you do get this performance, you don't want to sacrifice any of the nice features that vSphere already has, like vMotion or HA or DRS. These are some of the nice features that vSphere already has. So you don't want to compromise or sacrifice any of them in order to achieve this raw performance. And that's another thing that we ensured as we implemented this particular capability. I don't know if I answered your question.
Yeah, partly. I have another one about provisioning through vCloud Director. I mean, you didn't mention if I can, you said through vCenter you can provision SRIOV, but can you do it through vCloud Director and not Director?
Yes, so we can support vCloud Director-based SRIOV provisioning as well. That was launched. You
can or you will?
No, we can. So we just launched that 3 months ago.
Oh, okay.
The latest version of VCD supports SRIOV.
Which version is that?
9.1.
9.1. Okay, yeah. Thank you.
Sure. Any other questions?
There was a press release this week that said OpenStack is moving into the VMware Telco group. What does that mean?
Okay,
does it mean has more engineering focus, less engineering focus? Or does it mean it's not for enterprise? What does that mean?
No. No. Actually, what it is, see, OpenStack, I mean, from a VMware standpoint, we recognize that OpenStack is getting a lot of adoption and a lot of prominence in the telco industry. So as a result, what we are trying to do is to align our internal engineering focus also along with the business needs. So that's what is really happening. Right? So that doesn't mean that we are going to reduce the focus on the enterprise segment, or for that matter, it is less engineering resources and things like that. It's going to be the same. We will be supporting both enterprise workloads as well as telco workloads. But from an alignment standpoint, we feel this is going to be much better for an engineering operations standpoint. Okay. Yes.
Okay. Hello. Good morning. I have been working for a telco company. Indeed, we're planning to implement a virtualization solution in our platforms. So I have realized that there are many concerns related to microservices and also containers and also virtual machines. I would like to know what's the best practice for a telco ecosystem. Is it a good recommendation to implement virtual machines and also containers and also microservices, or is there any good practice? I don't know, maybe virtual machines for telco?
Yeah. So if you look at the infrastructure at large, right? From a VM standpoint, I think we are pretty mature in terms of handling telco workloads, both in terms of performance, carrier-grade capabilities, day 2 operations, and so on and so forth, right? So from a VM form factor. When it comes to the container, we are at the early stages. right? That's really the fact of the matter, right? But having said that, you talked about some best practices. So VMware has published best practices for deploying telco workloads on the VMware platform. So it's available in our website, so you're more than welcome to go and pick it up, or if you share with me your contact details, I can send you the links as well. So we do have best practice guidelines for deploying telco workloads on a VMware stack. So that will give you more information about that.
Okay, thanks so much.
Cool. Okay, thanks a lot.